And unfortunately, poor what? Repeatability. What do we mean by repeatability? If you throw a dart, and when you always throw a dart all at the same point, means you have what? Good repeatability. Be clear? Okay, so that's all. Okay, so I have a bit of story to tell you. Just take a short break. This happened to me in 2007, 2008. Approached by the US Army to test a material. Okay, so you say this is, yeah, I can't tell you what material up to today. So I have to test it. So 4 universities were picked: McMaster, Purdue, UBC, I think it was McGill. Okay, so they want all these constants to be done. Okay, and the project is worth $250,000. In 2008, it was a lot of money. Now it's worth nothing. Okay. I did phase 1 first, which is what? Which is the what? Yeah, the strain hardening. Okay. It looks normal. Phase 2, I could not get an oven to have a good repeatability at McMaster. I put on hold. I found a company, okay, that could do the strain rate. And I found the value C is equal to 6. So how I did this test, I told them to, can you test at the highest strain rate that I specified? I saw the value of 6. I call the company, or I call the institution, which is the US Army. What is this material used for? What does a value of 6 actually mean to you? Come on.
Highly ductile.
What does a value of 6 mean to you? So if you look at a stress strain curve, okay, so let's say this is the same material. C is equal to 0.01, for example. Okay, so for the black one, okay, so this is a deformation of 10 per second, and then over here this is deforming at 100 per second, and this is deforming at 1000 per second, for example. Okay, so this is C equal to what? 0.01. Now, when I did the experiment, I could not believe it. I was in shock, and the company will tell me, Eugene, you cannot go any quicker with our machine. If you go any quicker, we'll be in trouble. Okay, so I know, okay, this is done in phase 1. So this is C is equal to 6. I did not know it's 6 until I finished getting the data, do curve fitting. Yes or no? And this is at 10 per second. When I increased to 100, it was somewhere around here. So if I were to draw my stress strain curve, can you see what C equal to 6 actually means? So what do you do? As an experienced engineer like yourself, what will you do? I tell you what I did. I calculate how much money I've spent, which was about 79,000 Canadian dollars. I take the rest of the money and return it to them. I say I'm not going to be participating in this test. Any idea why? Hey? No. What is this material used for? What is this material used for? I'm asking you. What is this material used for? So I call them. Okay. What is this material used for? Oh, it's for like defense, body armor, right? If a bullet fire hit the person, the bullet is going very fast. Area under the stress strain curve is energy, dissipate the energy. The the human won't die. I say bullshit. It can be also be used as the what? As the bullet. Are we clear? Now, as engineers, we have to be ethical. Yeah, it's not like, oh, you pay me 250. It's good money for me. McMaster was so mad with me because whenever you do any research for an industry, McMaster got $100,000 worth of overhead. So if you give me $1 to do research, McMaster get 40 cents, I get 60 cents. Okay. So I told McMaster we have to return this. So they were so mad. And this is 2008. What happened in 2008? Yeah, economy crash. I returned the whole money. Moral of the story is this. What's the most important thing? Is it money or what? I'll tell you what's the most important thing. Any of you down here are above 50 beside me? To you, when I was at your age, the most important thing is what? Money. But you know what's the most important thing to me? Sleep. If I cannot sleep, okay, if you have bad sleeping habits like me, if you sleep less than 6 hours per day, what will happen? It's proven that your lifespan will be shortened by 25%. Sleep is very what? Yeah. That's why those of you who are taking 5 courses, 6 courses, you're shortening your life. Those of you who are taking 3 courses, your life will be longer. Hear me, 52, been there, done that. Are we clear? Okay, so with knowledge like this, okay, don't sit down and act dumb. That's not what we are for. I took the money and returned. McMaster is so mad at me. I'm fine. You can go crazy. I don't care. Are we clear? Most important thing is what? Sleep. Okay? Not about what? Nothing to do with money. Okay? So see again another useful aspect that you can see how these constants can what? Help you make what? Decision. Okay. It's not just it's a number, one of those numbers. No, man. Right? I doing when I was your age, to me, that it's like one of those numbers again. No, come on. It's more than those numbers. Any question now, right? So getting the test is not difficult. Now some of you might wonder, it's easy to pick the values, but which one will you use? Tensile, compression, or shear? Which will you use? There is no preference, okay? If you have no money, use what? Tensile. If you have money to throw, it depends on your application. If you are doing a lot of like your process is all in what? Compression, design the test for what? Compression. If you are doing a lot in what? Shear, do it in what? Shear. Try to mimic as close as your what? As your manufacturing process. Are we clear? Okay, not always tensile. Oh, always tensile. No. Depend on your what? Application. Are we clear? Right. So where are we now? So we have done strain rate effect. We have done how to determine the material constant. Now, next we are going to look at material consideration in design. Okay. Okay. So we come out with a, did we have a table? We have this. Okay, we have this. So let's look at this table now. Okay. So now you have an impression how these constants are determined, yes or no, right? You know how we get this data. Okay, so I've written this out last week, I think. Okay, so now when you look at all this value, right, you have an impression, yes or no? Impression of what? Mathematically, how your stress strain curve will behave with A, B, N, M, and C. Yes or no? Right? You have in your mind, okay, C is strain rate sensitivity. Now, question for you, an interesting one. If you look at the C value, what is an interesting value? What's wrong with Usbo? Yeah, right. Yeah. Usbo, if you look at 0, there it's like it's not, yeah, you're absolutely right. It's not what? Strain rate what? Sensitive. Is it true or false? What does Usbo have? Martensite. Anything with martensite is what? Strain rate sensitive. Like, look at dual phase steel. Dual phase steel has what? Austenite and what? Martensite. Yes? And the C value is what? 0.125. Right? But Usbo is just martensite on its own, 0. What does this 0 mean? If you look at A, B, and N for Usbo, what do you see? It's very high. Right? But why C is equal to 0? Anyone correct answer? I'll buy you a pint of beer. 2 pints. I'll bring the beer next week. If you are allergic to alcohol, I buy you 2 pints of orange juice. Anyone? Why Usbo is equal to 0? Or you want to have live betting? One guess, wrong guess, 25 cents to my hand. And then we go for everyone, and the right answer, the person get all the money that has been collected. What do you want? Anyone? Come on. Look at the values. Tell me something. Say it again. Huh? The hint is there. No hint. The hint is there. Why is it Usbo is equal to 0? Yes. No, it's not the most. I mean, it's expensive. Huh? You got it there. You drink alcohol or just orange juice? Huh? No alcohol or alcohol? Okay, then orange juice. More expensive for me, okay? Beer are cheap. The value is so high that they cannot deform the material at high strain rate. Okay, so this 0 is because difficult to get experimental data at different strain rate. Are we clear? Okay, not is like, oh, it's insensitive. No. It's just way too hard. Well done. Okay, well done. Okay, all right. So as I said, we are going to look at material selection. Okay, so we are now, okay, we are going to look at material selection. Okay. For a card structure. And I want you to learn from this, okay? So if we have, I'll start on a new page.